Hi, welcome to my channel Cloud with Girish. In this video, I don't have a hands-on workshop, rather I will explain few migration approaches for migrating a three-tier architecture application from an on-prem data center to AWS Cloud. Due to my keen interest in AWS Cloud, I am often approached by friends and colleagues in IT to share examples or opinions on AWS Cloud migration use cases. Since most of my friends work in IT, we share mutual interests and often discuss emerging technology. This weekend, one of my friends called to talk about AWS migration strategy and suggested that I create a video on this topic. Taking his advice, I'm creating this video to put together the key thoughts from our discussion, explaining the options available to migrate a three-tier architecture application to AWS Cloud. Migrating on-premise applications to the cloud offer numerous benefits such as scalability, reliability, and cost efficiency. This video explains the various options available when migrating a three-tier architecture, consisting of a web server, application server, and a Microsoft SQL Server database from an on-premises data center to AWS Cloud. So we will evaluate four options. The very first one is the application migration service provided by AWS. Second is the popular approach of containers using ECS and EKS services from AWS. Third, which is getting increasingly popular, is the serverless, the Lambda and other services. And then fourth one is database focus. So Amazon Aurora as a replacement for Microsoft SQL Server. We will also frame these options within the context of Rehost, Replatform, and Refactor migration strategy, which are three of the overall 7 R's typically looked at when you are migrating from on-prem to cloud. So let's revisit quickly the 7 R's of cloud migration. So migrating on-premise application to the AWS cloud can take various forms depending on the business goals, the application architecture, how much fund you have available, what is your timeline, the schedule, and the desired level of modernization. So AWS defines 7 common migration strategies known as the 7 R's. Each approach provides a distinct path to the cloud journey, balancing speed, complexity, the cost, the time, and the benefit of like cloud native capability. So let's look at quickly, starting with Rehost, which is a typical lift and shift kind of approach, the fastest way to go to the cloud. Replatform is another approach, repurchase, refactor, relocate, retain, and retire. So retire is pretty obvious. Like you look at it, say, hey, I have like 500 application. As I'm doing this assessment to move from on-prem to cloud, when I look at it, there are these 100 applications that business will not need going forward. So basically, we don't need to deploy those 100 applications in the cloud. Retain is also like specific use cases for a specific application. It could be a licensing reason, it could be a technology reason, it could be a business compliance reason, it could be a third-party software running. But whatever the reason is, let's say the decision is to retain those apps. And what I mean by retain is that you still have a subset of your on-prem data set where you're gonna run those. I mean, a classic example is like, let's say mainframe, right? You're not ready to give away the mainframe. So any process you have running on mainframe, you're gonna retain it while you focus on all the distributed computing migration path. Relocate is basically like you transfer the workload to the AWS cloud without like significant modifications, like VMware cloud on AWS kind of service. So you are running on AWS infrastructure. Refactor, this is where you spend most time and probably most funds because we're talking refactor and rewrite, right? So this is where you need to do a due diligence that which app you want to rewrite, which app you don't want to rewrite. But this is where you really reap the benefit of cloud native technology. So you may want to go from a traditional app to a serverless, or even if it's not serverless, you may want to utilize some of the cloud services, the native services. So that's where the rewrite refactor comes into the play. You need the most skilled resources, you need a good design, the architecture, and the long-term approach. Look at the performance, look at your metrics, and then you start on that journey. The repurchase is basically you are replacing, let's say, certain application with a SaaS-based offering rather than migrating the existing application, right? You may pick something from the marketplace, you may have another SaaS service, so you are basically repurchasing the solution, still meeting the business goals. Replatform, as the name say, you are making some minor optimization. Maybe you are taking a on-prem application and maybe putting it in a container, putting it in a Docker, using the EKS, Kubernetes for orchestration and so on. And the rehost, like I said, that's the simplest one. Basically, you are just doing a lift and shift. You got 1,000 servers in your data center, and you're gonna move all of those to the cloud, AWS. So you do move to EC2 and then you are in cloud. So that's 7 hours. Now let's look at in the context of what we want to focus on. So the application in focus that I have here, it follow a traditional 3-tier architecture. And I mean, I say traditional, but it's really been a very popular architecture pattern since, I think really became more popular when we went to the web, an app server and database kind of approach. But really even before web, right, the whole client server kind of thing, there was some aspect of it. But really with the web, J2E application, the .NET application, you had a Tomcat, you had a WebLogic, you had a WebSphere, you have Oracle database or a DB2 or Microsoft SQL Server. And if you are a .NET shop, then you had the IIS and you had the Microsoft SQL Server. So the point is that 3-tier architecture has been there in places, and it's still get utilized, right? It's basically you are separating the presentation layer with the business logic sitting on the application server, and then you are creating another separation which is in the data, so the database server. For this example, let's assume that we have an app with such kind of 3-tier architecture in an on-prem setup. So we have a web server, which is basically running an Apache HTTP and a Linux VM. And then we have an app server, Java-based application running on a Tomcat server. And then we have a database server like Microsoft SQL Server running on a Windows VM. So this is just a simplified view of it, right? So we have a web server, we got an app server, we got a SQL Server. When the consumer comes, invoke it, look for something, web server pass the information to app server get it from the SQL Server and return it back, right? Could be anything. You're trying to look at your account balance. You are looking for your customer information, you want to update your address, you want to purchase something, right? Could be anything, but that's like a typical 3-tier architecture. So let's look at the migration strategy that we will look at it in this context. So like I said, we're going to focus 3 out of those 7 that I was talking about. So rehost, replatform, refactor, right? Not looking at retain because we're not retaining it in the on-prem, not looking to retire because we're not retiring it, not replacing it with any SaaS offering. So let's just look at, we have this app, we will move it either rehost, replatform or refactor. So rehost, right? That's lift and shift, and basically you're just moving it to the cloud with minimum changes and basically replicating it just the on-prem environment, right? It has the speed, simplicity, probably the most cost effective in the short run, right? To get to the cloud. maybe not the most cost effective in the long run, but in the short schedule, it will move you to the cloud. The replatform, this is where, like, you need more skill set in your existing environment, but you are making some optimization and changes to take advantage of the cloud feature. You are not really re-architecting or refactoring or rewriting the application. You're just taking the existing one and making some subtle changes, right? Like you are maybe moving it to a container, like I said, and then you're going to move the power of like orchestration in the cloud. So that's just some minor optimization. And the third one is where you just want to rewrite it, right? So business rules, what this app does, and now like you don't need like it to run on 5 different servers with 6 different databases. You just want to looking at it something more cloud native. Maybe you want to go serverless, right? You want to use a Lambda function as a server kind of offering. You want to use an API gateway. You may want to use some event-driven architecture. So you want to use some messaging solutions. So all of that cloud native, looking at the greatest long-term benefits written on a ROI kind of, but it requires the most effort upfront. So let's look at like just a simplified view again. Rehost with AWS migration service is named at MGN. So if you are in AWS console, you can look at this service from there, but it's a rehost strategy by providing a straightforward lift and shift approach. So this basically simply involves moving your on-prem virtual machine from an on-prem environment to AWS without major architecture modification. So the way it works is that you have your on-prem server, you will install an migration application agent, a replication agent. So that will be like sitting in your on-prem server, and it will start replicating your app into the staging area in AWS Cloud, right? In EC2 and EBS kind of scenario. And at this time, your production is not impacted. Your on-prem app, your on-prem server is serving the customer without like any downtime, and it's replicating it in the staging area. Once this replication is done, it can be validated here, it can be tested here, and then there is a feature we say, hey, are you ready to cut over? And if you say, yeah, cut over this, then at that time, it will create a production area with what you have cut over, right? So any more replication changes that's happening here will not be reflected here because you have made a decision that, hey, everything looks good to me, I have validated, I'm ready to cut over. So now you got the production here, you can start using it and not worry about staging, right? Or you can leave the staging for some time, but it's not basically getting synced, right? So that's the production, like that's at a high level, that's how it works, right? Now, the advantage of this really the simplicity. Basically, you're not changing the architecture, you're not doing any code change, fastest way to migrate it, right? Of course, scalability, I mean, you will still have the benefit of scalability that cloud provides, which you will not have it in your existing on-prem environment. So you will still get it, but it's a limited scalability, right? Because the architecture, the underlying architecture is not changed. And then you still have the ongoing management. So you don't have the on-prem server, but you have servers in cloud. So you have to manage that and do your regular patching, the scaling, and so on, right? So that's typically the rehost approach. Now, let's look at the replatform with containers. So ECS, EKS, these are the services that offered by AWS, sort of equivalent of the Kubernetes. So migrating to containers, now that is considered a replatform strategy, because what you are doing is that you're taking the application which is not in container, but now you're putting it in the container, and then you are using one of these services without changing the core application logic. So again, in this example, you have a web and app server, so you containerize the Apache and Tomcat server using Docker and then deploy them in the container service, basically the Elastic Container Service or Kubernetes service, the EKS service. Databases, same SQL Server can remain on EC2 or be moved to Amazon RDS or Amazon Aurora for improved scalability. So multiple options there, of course, depending on how much effort and what your target architecture is. There are certain advantages here. So now because you are putting it in containers, so you have more portability, right? So for the runtime environment and so on. Scalability, because now you're using EKS for orchestration. Of course, the whole Kubernetes thing is more DevOps friendly and fit into the CI/CD pipeline and so on. Challenges, I mean, if your engineering team is not familiar with the container approach, then there is a learning curve, right? Because you need to train them, use the best practices, get some professional help, and basically build the Docker Kubernetes kind of solution. So not as straightforward, right? If you're talking thousands of server and hundreds of application, and some application may require some modification. So again, there is some work, right? It's not as complicated as rewriting the entire application, but still there is some engineering work involved here. And the third one here is really the rewrite, right? Referred as refactor, or sometimes you refer it as rewrite. But essentially here, you are basically saying, hey, I want to go like cloud native. I'm going to go serverless or whatever other approach. But let's say we're going to go serverless. That means I want to use Lambda for the function. I'm going to use API gateway. I'm going to use like one of the modern database like RDS, the Aurora service from AWS for my database solution. So that's a full refactor, right? That's the strategy. You need to re-architect the application. You break the web and app into like Lambda function, use the API gateway, you for handling the HTTP requests, right? You can combine it with other services like WAF and rate limiting and so on, right? But basically now you are looking at a fully cloud native design. So here, like, at a high level, your web layer, basically your API gateway handling the HTTP request and routing them to the Lambda function. And then Lambda function basically has this stateless Lambda function, which is taking the request, processing the business logic, and maybe like either it's working with the database, which is either in Aurora or RDS for SQL Server, or maybe it has other layers, right? It's a asynchronous kind of a communication. So maybe you have another messaging service, which is serverless, and you are using those services like SQS, the simple queue service, and so on from AWS, right? Again, the advantage, AWS managed services. So here, like, you don't have any server to manage. AWS is taking care of it. Lambda scales automatically based on demand. Cost efficiency, it's a you only pay for what you use, so making it highly cost effective for various workload. Now when I say highly cost effective, of course, you may debate it that hey, no, it's not, but that really depends on your use case, right? And how well you are controlling it. I often hear it that my cloud cost is high. Yes, it can be high if it's not managed. That's why you need to have that FinOps aspect of the cloud strategy. Keep in consideration, right, that you are paying to use those resources. So don't use those resources all the time if you don't need to, right? Do you really need some of your resources like 24/7, or do you like what kind of configuration you are looking for your function, right? How much RAM you need, what kind of computing power you need. The more you ask for, like Lambda function can support RAM up to like 10 GB. But do you need 10 GB for every single Lambda function? If you do, then you are looking to pay quite a bit of cost there. So but you can have your Lambda function as little as 128 MB, right? That's where it starts. So again, you have to look at like what kind of your business need is, what kind of data you are getting. So those are like some factor for you to look at. But again, the major challenge is like major rewrite of application. You have to fit it in the serverless event-driven architecture. In depending on which programming language you are using, you may have to like consider the cold start, right? So some latency related thing. Again, not everybody get into these kind of issue, but it again depends how much data you are fetching and what your architecture is, what your business use case is, right? How much performance tuning you need to do, and so on. What kind of library you are pulling in your code. So there are a lot of factors to look at. But these are the three approaches that I wanted to focus. And then the fourth one here is really just focus on database modernization. So this is basically you are replatforming or refactoring your database solution. So Amazon Aurora, this is a fully managed MySQL and PostgreSQL compatible database design for highly performance, and I should say designed by our AWS because it's a AWS service. Ideal choice for replatforming, refactoring is more cost efficient than some of the other services that AWS has. Like you can use RDS from AWS, and that's perfectly fine. Aurora is just comparatively cheaper because it's something that AWS native service and highly scalable. So here the web and app server, same thing. It can be migrated using whatever the migration service, the container or serverless, right? Whatever approach is picked up. And the database then can be replaced by Amazon Aurora, which can be done either as part of like, replatform strategy or a refactor strategy and modernized to cloud native architecture. So again, that's our database related options that we have. So in conclusion, like choosing the right approach in the beginning, that is the key. And not to say that you can change your approach, right? Sometimes some approaches can be changed, but again, depends on the overall goal that your organization want to take. Maybe you are in some sort of timeline that you have to free up your on-prem real estate for the data center, and you have to move to the cloud in a short span of time. In that scenario, the best solution will be like, use the migration service and get it running in the cloud so that you don't have to worry about retaining the on-prem real estate. So that's just one of the scenario, right? So choosing the right migration strategy depends on the organization goal, timeline, technical capacity, and of course the fund, right? So again, here is a quick overview which approach might be suitable based on Rehost, Replatform, and Refactor strategy. So Rehost is using AWS migration service, a fast and simple solution for migrating with minimal disruption. Best for organization prioritizing speed over modernization. Second one is like Replatform, and this is a balance between modernization and simplicity, allow for incremental cloud optimization without significant changes to the application code. And third one is the Refactor, right? That's where you're going serverless, Lambda, Aurora, long-term solution that offer maximum cloud native benefits like automatic scaling, cost saving. However, it requires significant effort to refactor the application. By evaluating these options and aligning them with the migration strategy, business can choose the approach that best fit their goal, timeline, cloud maturity, etc. AWS provides the flexibility to evolve from a rehost to a replatform and eventually to a refactor approach as needed. I hope you enjoyed the tutorial. I'm constantly working on new content covering various AWS topics, so please take a moment to like the video and subscribe to the Cloud with Girish channel. Your support helps me continue creating valuable AWS tutorial and workshops. Stay tuned for more exciting content. Thank you.